Hess law, I think, talking about Hess's law today. This is another way of finding out delta H. Remember, delta H is enthalpy. We're talking about enthalpy. We're talking about heat of reaction. Mask over nose. Okay, Hess's law of enthalpy change reaction, whether it occurs in one step or a series of steps. Okay, so in this way, we don't typically use the delta H, the standard delta H values. It gives you the delta H values of each step. Okay, it gives you delta H values each step. So kind of like Dalton's law of partial pressure, the total delta H value is the sum of all the other delta H values, the sum of all the steps of delta H values. So delta H reaction is equal to delta H reaction A plus delta H reaction plus B plus delta H reaction plus C. I like to think this as an elimination problem. Okay, you all have done elimination in math. When you have two equations and you set it up that way, you might have to multiply the top reaction by 3, or something like that to get the x's to cancel. That's what this is. So if we modify the reaction, we have to modify the delta H. What you do to one thing, you do to the other stuff. So if you multiply the reaction by a number, delta H, you multiply by the number. So if I know that I need 2 of A's, okay, 2 big A's, I multiply everything, the whole reaction by 2, I have to multiply delta H by 2. If I divide it, I divide it by 2, okay? If I flip it, I flip the sign of delta H. Those are the easier ones to see, okay? Those are the easier ones to see, like that, okay? If it's negative, it becomes positive. Positive becomes negative if you flip it. So, Hess's law example. Here's the question, okay? Here is the question. This is how this question is set up. So, calculate delta H for the reaction. 2N2 plus 5O2 yields 2N2O5. So in this case, what we will say is we can't find the delta H value of N2O5, okay? Because we actually know the delta H of N2 is 0, delta H of O2 is 0. So, but we don't know the delta H value of N2O5. That is not explicitly given in our table. So we have a thing like this. This is a 3-step reaction. So in the first reaction, N2O5 reacts with water to make HNO2HNO3. Another reaction, N2 plus O2 plus H2 makes HNO3, and then H2 plus O2 yields H2O. So this is what this equation is given as. So now what I need to do, is I need to find the delta H for the total reaction. I need to find the delta H for the total reaction. So and the notes explain it. Also, if you go back and look at the notes, the notes do 100% explain the math behind it. Where's my mouse? You might sit there. So here's the same question. Here's the same question. So how you do this is you want to make the bottom 3 equations in this case look like this top equation. You want to make the bottom 3 equations look like the top equation. So I'll take them one by one. All right, so here's how we do this, okay? So here's my total reaction. So I want to look at each one of these stepwise, okay? I want to look at each one of these stepwise. I know I need N2O5 in the products, don't I? In my step 1 of the reaction, where is N2O5? In the reactants. So that means I need to flip it, don't I? Do I need to do anything else to it? Okay, I need to flip it. That will change the sign, okay? But do I need to do anything else to it? How many N2O5s do I have? How many N2O5s do I have in the reactant? So I need to multiply it by 2. So times 2. And flip, okay? Multiply by 2 and flip. Does everyone understand why that happens?
So that's all worth it, right?
Well, I mean, I'm going to work it out. Okay, I'm going to work it out. So I'm going to have, so multiply that by 2. So I'm going to have 4 HNO3 yields, I'm going to not put the states on there right now because it's too hard for me to write. 2, but sometimes they do matter because you might have liquids and gases. 2 into O5 plus 2 H2O. And my delta H equals positive 76.2 or 76.6 times 2. Okay? Because I flipped the sign, so it was negative, so it became positive. Okay? And I multiplied by 2, so I need to multiply the delta H by 2. What? N2O5. 2 N2O5 plus 2 H2O. Now, in my second equation, so I'm done with my first equation, okay? What? Well, you put in that in your calculator when you're done, okay? You put that in your calculator. I mean, it's 150, what? 153 equals, so instead, so I can say that equals 153.2. So second equation. Okay, second equation. Let's look at it. What? I go by through and look at this, and I see, does something appear in the second equation that appears in the overall equation? So something that appears in the second equation that also appears in the overall equation. N2 appears in both equations, doesn't it? Now, is it appearing on the correct side? Yes. Okay, it's appearing on the correct side. We'll look at N2 first, okay? Because I'm going to look at N2 because I have O2 down here again, don't I? So I'll deal with that one in a second. So, do I have the correct number of N2s? No. I need how many? And I have how many? So what do I need to do? Multiply by 4. So I multiply that by 4. I'm also going to multiply delta H by 4. I'm not flipping it, am I? So that gives me 2 N2 plus 6 O2, because 4 times 3 halves, plus 2 H2 yields 4 HNO3. And what does delta H would equal? Negative 174.1 times 4. So what's that, Balin, since you have the calculator out? $1,143. No, it's not. What, negative 174.1 times 4?
Negative. Oh, I was looking at 285.
Sorry. A negative 174.4 times 0.1 times 4.
Negative 696.4.
Negative 696. That's a negative sign for everything. 696.4. So I'm done with that equation. Okay, third equation. This was the most difficult one, correct? What do you think you need to do to this one? Anybody, what do you think you need to do to this one?
I mean, you think based on what we did on the other one, you have to multiply by 10.
Multiply by what?
10.
10?
Yeah, you have to 1/2
1/2
O2.
to get to
And
5.
you need 5 O2.
Okay, I see that. But, however, don't I already have O2 somewhere else in the reactants?
So you only need to multiply. So you only need to have 4.
So, here's my question. And I only need 5 total. Does H2O appear in the overall equation? So you know it has to cancel out, don't you? So we know that H2O is on the products in step 1, don't we? So to get it to cancel out, we need it in the reactants, don't we? So we got to flip it. Okay. And multiply by 2 because I need to, so I have 2 H2O here and I need to cancel all those out. So multiply by 2 and flip the sign and flip the equation. So I have 2 H2O yields 2H2 plus O2, and delta H would be equal to negative, or being positive, 285.8 times 2. Equals 571.6. Now, a double check mechanism, just go through and make sure you did everything correct, okay? 4HNO3, do you see that anywhere else in one of these other steps when you add them together?
What was the final answer?
571.6. I have 4HNO3 right here, don't I? I have 4HNO3 right here, don't I? Those cancel. I have 2H2 right here, don't I? I have 2H2 on the other side and the products on the other one. H2O's cancel, don't they? Now, I have 1O2 here and 5O2s here, so what would that be? Or 6O2. So this one goes away, and this one becomes 5. Now I have left 2N2 plus 5O2 yields 2N2O5. Is that what my overall equation is? So that's just a double checking mechanism, okay? That's just a double checking mechanism. So my delta H would equal 153.2.
Why did the O2 go down?
Because I had 1 on the products and 6 on the reactants. So I had combined like terms.
Okay.
So 153.2 plus negative 696.4 plus 571.6. Yes. I believe I got here for my delta H from each individual reaction, okay? My delta H from each individual reaction. I think get 28.4.
This seems hard.
We'll do another one. You good? Next reaction. So here's our equation. Okay. So let's go look at these. What I need to do the first equation. First equation, what I need to do to it?
Multiply by 6.
Why?
Get 6 carbons.
I need 6 carbons, so I'm gonna multiply by 6.
Okay, I have a question. How do you know what to start with?
Just start with the top one. I just start with. I mean, there's
No,
no.
I mean like, why couldn't I multiply by 3?
Because that's a good question. It's O2 appears in every equation, doesn't it?
Yeah.
O2 appears in every equation. So that's why I can't. That's why I'm not going to look at that one. Okay, I'm going to look at what appears in the one equation.
Saying, does it matter what you start with?
Yes and no. You typically, it's easier to start with the thing that appears the least. Okay, one time. So I have 6 here, so I multiply this by 6. Multiply delta H by 6. Okay, so I'll have 6C. I'm not going to write the states on this again. Plus 6O2 yields 6CO2, and the new delta H value is like negative 2,361.06. That's that number times 6. Right, second equation, what I need to do? Multiply by 16, because I need 6 H's. I only got 1 here, so multiply by 6. So that gives me 6H2 plus 3O2 yields 6H2O. And delta H is 1800. It's going to be right around 1710.
Negative 1,714.98.
I mean, look at me, significant figures. I would have been correct, but it's 3 significant figures. All right, and last equation we want to do. Flip it. Okay. Anything else? Nope. I got one of these, one of those. So I'm going to have 6 CO2 plus 6 H2O yields C6 H12 O6 plus 6 O2. And so delta H now is positive 2,803.02. That's a pitiful job of writing.
So is this just the final answer, the canceling part? You know.
I mean, I don't really care if you cancel. The canceling is just a double check mechanism. Okay. I need to do this stuff here. Okay. That way I can know what to multiply stuff by. So really, all I need is my delta H value. Okay. All I need is negative 2,361 plus negative 1,400 plus 2,803. And I think you get negative 1,273 on this.
Oh, so your answer is just always delta H is out.
Yeah. Now, I don't need, I mean, I already know the equation, okay? So it's kilojoules. All I do by canceling it and stuff is just to make sure everything's correct, okay? So 602, 602. H2O's cancel. CO2's cancel. So all this part of it is just a double check mechanism to make sure I multiplied and flipped everything correct.
Okay, what's the answer?
Negative 1273.02. That's Hess's law.
No,